Physical Science Exam 2015, question 15. Okay, information for 5 substances A, B, C, D and E, not their correct chemical symbols, is given in the table below. 4 of the substances are elements and 1 is a compound that is formed by reacting 2 of the elements together. So 4 of these are going to be elements, so they're just by themselves, and 1 is a compound by reacting 2 of the elements together. So there's a combination of those. Complete the column state at room temperature for substances B, C, D and E. So we've got to fill that in up there. Well, remember what state is. If we have got water, for instance, and I have a line going through from there, then, and this is temperature, and that'll be 0 degrees, and that's 100 degrees Celsius. Then this is going to be a liquid in here. This is going to be solid, and this is going to be gas. Of course it is. So water, when it's below 0 degrees Celsius, is a solid, but at between 0 and 100 it's a liquid, and then after 100 it becomes a gas. So what we need to do, and that's if we're at about here, say at 20 degrees Celsius, which is typical room temperature, then what we might have is that it's going to be a liquid there. Now, some of these things. Look at substance A, for instance. 1000, the melting point. So what this means is, this is the melting point. If you have got a solid, if you're going this way, that's melting. If you're coming back this way, you're freezing it. If you cool it down so it goes from a liquid to a solid, then it's freezing. When you think about ice, that's okay. Now, boiling, that's going to be the boiling point. And sublimation. Condensation. When you're going from a gas back to a liquid, it condenses. You see that as well. That's what, when we're distilling things, you can condense things and go back from the gas situation to the liquid situation. So that's what that means. So at these points, that's what these things are. Now, so for instance, in this case, the melting point is 1410 degrees, which means if we're down here, the melting point is way up here somewhere. Okay, so what that means is, and the boiling point is beyond that. So what that means is, if this is, we are on this side of this melting freezing line, so therefore this is going to be a solid, and that's what we've got with the first one. Let's have a look at some of the rest of them. So this melting point is 858 degrees. Imagine it's about 20 degrees at the moment. This one is going to be a solid. This one, 63 degrees. This one melts at 63 degrees. That means if you put it in water and heat it up, or say really hot water, it'll start to melt and it'll become a liquid. So that means at the moment that it is a solid. This one, melting point, is minus 39 degrees Celsius. That means you have to go back this way to turn it into a solid. Now the boiling point is 356 degrees Celsius. So we are in the middle there. So the 20 degrees will be in the middle of those two. So what that is a liquid. And this one, the melting temperature to go from, if we're going to go from a liquid to a solid, it's going to be minus 220 degrees Celsius. But the boiling point is minus 188 degrees Celsius, which means that we are above that. So if we're above the boiling point, that means that we're looking at a gas there. So that's what's going on. What is uncommon about the properties of substance D at room temperature? Well, remember that you've got your information sheet and you've got general characteristics of different structures down here. If you can see that okay. This is on page 3. Have a look at these ones. Now, we are looking here at some of these. Electrical conductivity in a solid and in a liquid molten state. So what we have here, D, it's going to have high electrical conductivity and high electrical conductivity in both the solid and the liquid or molten state. Now, is there anything here that matches up to that? Electrical conductivity, when it's solid, conducts. Okay, so it's going to be metallic. It's the only thing that we have that it conducts when it's a solid and is molten as well, because all these are non-conducting in the solid form. So in that case, so it's a metal, but the thing is here it's a liquid. What is uncommon about the properties? It is a metal and a liquid at room temperature. Can you think of any liquids at room temperature that are metals? We'll come back to the in a sec. Two of the substances are non-metallic elements. Identify these substances and justify your answer using information from the table. So what we're looking here is looking at non-metallic elements. So we're not looking for a compound and we're not looking for any metals. Well, for a start, we can rule that one out because we already said that it's a metallic. Okay, so it leaves us 1, 2, 3, 4. I would guess strongly that the fact that it's a metal and that it's a gas at room temperature, we can rule that one out. So what we have here is that we have these ones here that are solids at room temperature. Electrical conductivity. Two of these substances are non-metallic elements. So if they're non-metallic, we know that if it's metallic, it's going to have electrical conductivity in a solid state, high, and it's going to have electrical conductivity in a liquid state, that one and that one. So I'm reckoning that we're looking at the idea of non-metallic is we're going to have A and B. Oh, hang on. No, that's not right. Two of these are non-metallic elements. So this one could be a gas. I mean, I'm not looking for a metal at all. So yes, E comes into play. Of course it does. Sorry about that. So we've got either A, B, or E. And the fact that that is, let me have a little look here. So C and D are going to be metals. I'll cross that one out. That one's a high and high, so that one's going to be a metal, and that one's going to be a metal. B has the properties. What we have here is, looking back here at B, what we have here is a nice firm solid. When it's an electrical conductivity in solid state, so when it's nice and solid, it has no electrical conductivity. But when you dissolve it, it does actually become a good conductor, which is, if you look down here, ionic compounds, this is the structure of ionic compounds. When they're solid, they're non-conducting, and when they're molten, they conduct when they're molten, or if they're soluble, they conduct. So these ones are non-conducting and these ones are conducting. If you've got covalent molecular or covalent network, they are non-conducting at all times. So what that means is that is more likely to be, this one is more likely to be a or an ionic solid, which means that A and E are most likely to be they are likely to be the non-metallic elements. Okay, if they're non-metallic, then they don't conduct. Okay, so A and E. Justify your answer using information from the top. They are non-conducting in solid and liquid, molten form. Now, that doesn't mean necessarily that they are elements, but if we have a look at the S, so we have a look at B, prob ionic compound, electrical, due to its electrical props. C is going to be prob metallic solid, and D is likely to be metallic liquid. So there you go. I hope you got through that. I hope that made some sense. Which one of the substances is the compound? Give reasons for your choice and identify the type of bonding in the substance. Well, we can do that. We've done pretty much all that. So we're saying that B is probably an ionic compound. It is a, let me have a little look here. What have we got from the information? Solid at room temperature. So the reasons we're saying that is that it is solid at room temperature, does not conduct electricity when it's a solid, does conduct electricity when it's liquid and molten. So solid at room temperature. Solid at room temperature does not conduct electricity as a solid. Does as liquid. Okay. Referring to your answers and the information given in this equation, complete the table below, giving one possible real name for each substance. All right. Well, let's have a little look here. Okay. Possible names. So this is not by any means a definitive list. Some of these are going to be pretty sure. So a liquid metal pretty much is going to be, so we'll start with that one. Mercury, Hg. You don't have to put the symbol if you don't want to. But let's have a look. What have we got here? Okay, what else have we got here? We have got a so this is going to be a solid, and it's going to be a very high boiling point. Let me have a look here. It's got no electrical conductivity, and it's got no when it's either a solid or a liquid. So that's going to be an element, we've said, and it's going to be a non-metallic element. So we can go over here and have a look at non-metallic elements, and we might choose one, something up here. Silicon maybe. But any of these solids, there's no reason why you couldn't choose phosphorus or sulfur or anything like that. You couldn't choose one of the gases, obviously, at room temperature, but we'll go through from there. So the next one, B, is going to be, it's still a solid, and electrical conductivity, we said that B was probably going to be an ionic compound. Your melting point is going to be quite high. I mean, there's no reason why any of these ionic compounds, if you put them, they shouldn't be considered to be correct. So you could, even if you put, I mean, it doesn't. You've no way of telling what the actual properties of these are, so long as you put an ionic solid. So you could put sodium chloride, for instance, or you could put potassium chloride or potassium fluoride. Fluoride, is that right? No, I always do that. We're not having potassium fluoride, that would be ridiculous. Potassium fluoride. C, what did we say C was going to be? C was going to be a solid, but it's got a low melting point. It's probably a metallic solid. I wonder what that might be. Let's see, it's a solid. Boiling point, it's got a low melting point. So what's a low melting point solid? So long as you put probably a metallic solid, so any of those metallic solids, something along here, I don't know, calcium or I don't think it's magnesium, but if you were to put magnesium or something like that, calcium or potassium, something like that, so long as you could justify the fact that it was a metallic solid. And the last one is going to be a gas, and it's going to be an element. So you might put down something along those lines. Any of these gases. So nitrogen, oxygen, fluorine, maybe even neon. I don't know. Let's put down oxygen. So long as you put down the fact that it is a gas in that case, and you go through from there. Cool.